Assalamualaikum and good day to everyone. We are now looking at chapter 4, that is on distribution of random variables. If you look at the title there, the random, of course, it's something that you don't choose on purpose. Variables is something that you're referring to something that is not fixed, something that tend to vary, like what you have seen previously in your previous chapters. There are a few things that you need to know from this chapter. Specifically, we are looking at our discrete variable. This is what we are going to do for this chapter 4. Continuous random variable, we will do it only in chapter 6. And of course, for this chapter also, you need to know what is probability distribution, and you need to understand the frequency distributions and the probability distribution. And also, for any type of distribution, you need to understand how to find the mean and the standard deviation. So this one, basically, you are doing back of what you have done in your chapter 2. So let's take a look what is random variable. Alright, in this case, of course, the definition is referring to variable whose value is determined by outcome of a random experiment. Alright, so meaning that you are doing it in random. Now, looking at the example here, you are having number of vehicles owned, the frequency, and the relative frequency. So if you still remember, you have done your relative frequency in your chapter 2, where you're taking frequency for one category, and then you divide by the total frequency. Now, this relative frequency is also your probability, because you're taking that particular frequency divided by the total, similar to the concept of probability. Now, these are examples of your discrete random variable. You're talking about you're doing for something that cannot be divided. For example, houses. Now, you don't have 0.5 house. Number of cars, okay, 1 car, 2 car, 3 cars, and so on. Number of reports, okay, 1, 2, 3, 4 reports, and of course number of fish on a fishing trip. You don't have, for example, 2.67 cars. You don't have 3.75 houses. Okay, so you are doing something which is discrete, which you can count one by one. If we look at our probability distribution, again, we have our probabilities. Okay, you can use the formula, right? And also, of course, you can have it in table or graph. Okay, let's take a look at example 1 here. Again, this is what you saw just now. You have the number of vehicles owned. So 1, 2, 3, you have 0, you have 0, 1, 2, 3, 4, and you have the frequency for each number of vehicles. You also have the relative frequency, which is also your probability here. So assuming we have this relative frequency, so if we put the probabilities or the relative frequency in table, it can be something like this. Alright, so X here is referring to the number of vehicles just now, 0, 1, 2, 3, and 4. And the bottom here, which is your second row here, this is referring to your probabilities or your frequency distribution. So please take note, this table here is also called your probability distribution. Please bear with the writing here. Okay. And also you have the charts here. This is to represent your probability distribution in a graph, right? So if you look back, this is again your probability or also your relative frequency, and you also have the number of vehicles owned, 0, 1, 2, 3, and 4. So please take note, your probability distribution is always in the form of table. Now let's take a look at example 2. Now you have here a number of days. Okay, number of chainsaws it runs each day during a period of days. X denotes number of saws. Okay, this is your X. And you need to construct a probability distribution and graph for the data. So you are given this table here, okay, the number of saws and the number of days. Okay, 0 number of chain for 45 days, and then only one chain was rented for 30 days, two chains were rented for 15 days. So if you calculate for the probability for each of the number of chainsaws here, so when X is 0, you have 45 out of 90, so you get 0.5. And then you do the same when the X is 1, when only one chain was rented, and then 30 chains out of 90. And lastly, you also do for when the chain was two chains were rented, so 15 days out of 90. So these are the probabilities, and then you put back your probabilities into the table. So this is again your probability distribution. The table is also called probability distribution. Okay, next. Now if you look back at your probability distribution, the one in the table there, you can construct it into a graph. Again, we are looking at line graph here, line charts here. So go back to your probability distribution, and of course you have here your X, that is your number of chains, and of course the probability distribution here. So when X is 0, this is approximately 0.5. And then you also do for when X is 1 and also X is 2. So basically you write back, you draw your line according to the height. Okay, you check back with the frequencies there, the relative frequencies, or also your probability distribution. Okay, example 3 here, this is where you're doing back for your joint probability, that is from your tree diagram. Okay, if you okay, it's telling you here now there are 10 cows, and of course 6 of them are males. Alright, so you have here 6 out of 10 for males, and then you have 4 out of 10 for female cows. And then it wants to see without replacement, 2 cows were selected from the farm. Alright, so you need to construct a probability distribution when X is the random sample representing the number of male cows only the male being selected. So you need to construct the tree diagram from the beginning. Firstly, of course, when the first cow was selected, and then the second level is when the second cow was selected. So firstly, you have 6 out of 10 for males, again 4 out of 10 for females. And then secondly, because we have without replacement, if one cow had been selected, means there are 9 cows remaining. So second male means 5 out of 9, 4 out of 9 for females, and then again you do for the second level here. So you have to construct your tree diagram from the beginning. And of course this part here is where you okay, now this is again how you do it. I hope you still remember. 6 out of 10 times 5 over 9. Okay, hope you still remember how to get the joint probability. So you get all the joint probabilities for all 4 events here. And of course, once you have finished with your joint probabilities, you construct your probability distribution. So all these joint probabilities here, you put back into a table. So this table is again called probability distribution. So notice our X here is referring to number of male cows. So when there is no male cow selected, okay, X 0, so you're referring only to female and female. So female and female 2/15. And then when only one male cow was selected, you are looking at these two probabilities. So 4/15 plus 4/15, you get 8/15. And then lastly, when there were 2 cows selected, then finally you get 1/3. So this is where you get your probability distribution straight from your tree diagram, but of course you need to construct your tree diagram. Alright. Okay, please remember our rules of probability. Value of probability must be from 0 to 1. Total probabilities is always equal to 1. Now, let's say you have this example here. You want to find probability that number of car sales per day. Okay, X is 0. Okay, so X is 0, 1, 2, or 3. in this case, you are given straight away the probability distribution. So you want to find probability that the number of car sales per day. Question 1, none, means you're doing for X equals 0. So X equals 0, straight away you get 0.1. Exactly 1, again you take when X is 1, 0.5 from the table. And then lastly, you want to find number of car sales per day from 1 to 3. In this case, 1 is included and 3 is also included. So you take into account X equals 1, X equals 2, and X equals 3. So you total up all the probabilities for X1, X2, X3, and then you get 0.9. Alright, and this is where you need to find for probabilities when number of car sales is more than 1. So more than 1 means you're looking at X equals 2 and X equals 3. Okay, so you add 0.3 and 0.35, so you get 0.65. And at most, finally, for question E, at most 2. At most means you're looking for X equals 0, 1, and 2 only, meaning that the 2 is the maximum number at most. So you take probabilities for X equals 0, X equals 1, X equals 2, 0.1, 0.25 plus 0.3, so altogether you get 0.65. Okay, we stop here. Okay, because next part I will continue with the mean of discrete random variable.